Look at that.
Yeah, wherever you want. In front would be easiest.
It would be. It sure would be. Can I plug this? No. No. Okay, I will put this here. All right, hi everyone. My name is David DeCarpy. I work at Arab. Started as a structural engineer, and now I lead a team of software developers. And I've been looking into what the VFX industry has been doing. And if there's anyone in the room that knows more about USD than me, I apologize in advance, please correct me. But what I would like to share is basically this question, okay? USD, you may have heard of it, Universal Scene Description. Apple uses it, Pixar invented it, NVIDIA uses it. And are these co-workers, IFC and USD, can they work together? Are they cousins where they're kind of doing the same thing, but they're kind of unrelated? Are they siblings where there's a rivalry between them? What's the state of play? So the narrative that I'm going to flow through today is just give some background to USD. Where did it come from? What was it trying to achieve? And then I'm going to dive into explaining how USD does these things, or some of the choices they've made. We're talking about some of the choices that we have. So I'm not going to present the choices as we should do this. I'm just going to say these are the choices they made when faced with similar bifurcations. So one is the structure, and the second is the construction. Talk about schemas, validation, and then I've got one little slide on how USD is organized as a not as a technical thing, but as the people. And then a little recap. So let's dive in. So the first thing to talk about is the VFX industry, and I want to compare them a little bit to our industry. So the VFX industry, well known, it's a creative field. You can debate whether our things are really creative, but the fact is we're an industry that creates things. You know, we make things. They're two creative fields. They have, VFX is visual effects. So animation, so computer-generated imagery, all that kind of stuff. Pixar is Industrial Light and Magic. They have insanely tight production deadlines, as do we, right? You know, in terms of whether it's getting the drawings out or getting the construction built. They have enormous teams, lots of people. You know, you see the credits flow through at the end of the movies. In terms of the number of people involved in the design and the construction of the building, we also have enormous teams. They have a huge number of disciplines, right? They have modelers, they have riggers, they have animators, they have shaders, they have lighters, they have, you know, on and on and on and on. As do we, all the different engineering disciplines, the architectural, you know, the different specialties within architecture, all the different trades, all the different generalists, these enormous things, these enormous teams and diverse teams. They have a lot of data, and so do we. So we have a lot of data. So on the surface, the visual effects industry and the construction industry have a lot of differences. But when you look into, there is an overlap in terms of the challenges that we both face. So at the beginning, and these next few slides are copy-pasted from the OpenUSD website. So this is just sort of presenting what they say about themselves. So the mandate for this project, when it started within Pixar, was to marry a composition engine, and we'll talk about composition and define it later because it means different things for them than for us, than for IFC. A low-level data model with a lazy access data model and a lightweight scene graph, right? So the things that they say here is composition, so pulling together data from multiple different places, the scene graph, how you organize things, and a data model. In there, we don't have anything about geometry, right? We think about visual effects, we think about 3D geometry, geometric data. In their starting mandate, the animation died, that's very sad. Anyways, it's actually it's not about geometry, right? And then if you ask them, again, this is not me telling you why we should use USD. This is USD telling the VFX industry why they should use USD. They say that it facilitates the use of multiple digital content creation applications. And the DCC is their word for, you know Revit and Tekla and SketchUp. You want to allow multiple artists to collaborate, and you want to maximize iteration, right? So here you've got multiple software working together, collaboration, you got iteration, again, the fundamental things, this is not solving a geometry problem. This is not why USD exists. USD does not exist to solve geometry problems. They're like, yeah, we know how to do geometry. The hard part is these other things, is collaboration and all that. So the point of this presentation is to just pique some interest and give you a first step into what USD is. Please don't expect to fully understand everything because I only have half an hour and I don't fully understand everything. So if there's stuff you're like, I don't quite get that, that's okay. So the idea is that USD says that it can pull together a data set from different authors. And you can have conflicting opinions, you can have catalogs or libraries of data that you can access. You can extend it and customize USD. You have an asset resolution mechanism to pull in other assets that may or may not be USD. It has support for multiple different file formats. It allows you to specify your own data schemas and extend it. It can represent geometry, shading, models and assets, more things like that. And then also with a thing called Hydra, which is part of the project but separate from USD, it can actually render things. So here we finally got to visualization. There is graphics in it, there is 3D data in there, but it's built on the core. So they have this quote as well. They say, time is money, and relying on a predictable tool set which promotes collaboration between departments in a non-destructive way is fundamental to achieving feature film production deadlines. And I thought, hey, time is money. And if you just change out departments for designing construction firms and feature film production deadlines for construction deadlines, well, they're trying to solve a lot of the same problems that we are, and they're facing a lot of the same challenges that we are. So to recap, USD exists not to solve graphics or 3D problems. It exists to solve data and teamwork problems. The core mechanism is at its core of USD, and I'll get into the details in a second, but is a mechanism for non-destructive collaboration on structured data sets. Right? The core is not geometry. The core is this collaboration stuff.
What is non-destructive?
Non-destructive means that if I say something or I add some data, the original data set is there. So if you send me a data set and I add something to it and I pass it to somebody else, they still have full access to the data that you sent. I haven't removed any data. I've only added. So maybe additive is another way to say that. Geometry and visualization aspects are built on top of that core, and it's also extensible with other domains. So, any questions so far? Okay. So, the structure of a USD stage. So, when you get a USD file and you're looking at it, what do you get? What do you see? So, first, some terminology. So, in IFC, we have basically, let's just say we have models, and in the model we have objects. So in an IFC, we call the model an IFC file or an IFC model, and we have objects inside of it. In the ECS world, we have, a world. I'm not quite sure what the word is for all the data set together. It seems to be like, it's used a lot in video games, so it's like the world that you're in. And then the thing itself is an entity. In USD, when you open a file, you get a stage. And on the stage, there are prims. That's just the word they use. But the data set that you are looking at is a stage. And you can think of the model being organized in some kind of hierarchy. I'll skip ahead because this is the same slide. So when you open USD, you get a stage and you get a tree of prims, of primitives. But maybe apparently 3 syllables is too much, so it's down to 1. Each of these prims can conform to one or more data schemes. Each of these prims can have attributes and properties, and the difference between an attribute and a property in USD is a performance thing. It's not really important not as important from a data modeling perspective. There can be children. So at every node, you can have properties assigned to that node and also children assigned to that node. And you can also express arbitrary links between them. So you can say, hey, this thing is connected to that one or is related to that, but we'll get to that in a bit. So Now I'm going to dive into a question of graphs versus trees just to explain some of the choices that USD has made. So if we think of a graph being a set of nodes that has edges connecting to them, kind of linked data, right? When you want to compute values on that, you first are going to have to do some kind of graph traversal and get some data, and then bring it back. And this is very, very expressive, right? You can express kinematics with this, you can express connections and any kind of data flow. On the other hand, if you have a tree, you can have a set of nodes that are related by directed edges, where every node can only have one parent, right? That's the sort of the specialization of graph versus tree. And if you're going to compute a value on a tree, it can only depend on its parents and maybe its children. So there's like a strict subset of the tree that you need to care about when you're doing a computation on a tree. So we've talked, I think yesterday we were talking about semantic geometry and computed geometry, or explicit geometry. When you have semantic definitions of objects, you need to do this graph traversal to get the input data you need. Like, for example, you have a wall that goes from level 1 to level 6. You need to go traverse the graph to find level 1, level 6 to find out where they are. And then to render that, to show that, to do anything about it, you need to know what the vocabulary is, so you know what to hunt for. You need to know what these things mean, and you need to know the algorithm for computing it. On the flip side, if you have an explicit geometry scene graph, right, you explicitly define all your geometry in Cartesian space, which is separate from, what kind of geometry you can express. You can potentially have a large geometry core kernel or a small one, but it's all explicitly defined. And this is what USD has chosen to do. You have a single hierarchy for organizing your model, but also for placing things. So when you organize things in a hierarchy, every node of that hierarchy can have a transform, a Euclidean transform on it. And so when you want to place an object, you can traverse the tree, and as you traverse the tree, you can build up the transform. And as soon as you come to an object, you know what the transform is to drop. Yes?
Is it fair to say the relationship is containment, or is that? I mean, because you could have multiple graphs, but you have one tree, and that tree is apparent is analogous to our building space, or is it not? Is it too simplistic a way of thinking about it?
So USD has basically said there is a primary way of organizing it. You can have secondary ways of organizing it as arbitrary graphs, but the primary way is you organize it, and when you've organized it that way, you also must do the relative placement of the geometry.
It's really just about placement, and I shouldn't think about it like containment. Like you have a group in the group moves, right? And it doesn't matter if they're contained or not.
Correct. I think containment is a separate thing. Yeah. So it's a strict tree, but then when you render it, all you need to know is what the geometry primitives are and what the Euclidean transforms of the parents are. So if we put these side by side, you've got explicit geometry, like pretty straightforward. Semantics are an optional overlay. You can still express the semantics, but to get the geometry out, specifically for geometry, you don't need to understand the semantics. Parametric models, these are actually useful for authors, because when I'm authoring, I want to have a small number of really powerful levers. I want to move a level and have everything, redefined. USD has made the choice that in the geometry parts of USD, it's explicit geometry. So here's a couple quotes. They say, interchange is an important aspect of USD, and we are not currently willing to tackle the conformance problems of different data flow semantics between different DCCs. So, for instance, if different authoring applications choose to have different parameters for a wall that goes from level 1 to level 2, I mean, that's a fairly simple example, but different ways to compute and different ways to do that, they're like, well, hang on, that's making it tough, right? And then it says USD does not interchange computational data flow graphs as found in programs such as Revit and Tekla, for instance. In our case. Now, I will just caveat that because it actually can interchange the graphs. You can express the data flow graph, you can express that, but the core parts, like the out-of-the-box USD, ignores that when it's computing geometry. However, USD shade, which is part of the rendering thing, they do have a data flow graph. So they refer to rendering materials and all that kind of stuff. So it is possible, some bits of it are, but from a geometry perspective, from the core geometry, they're like, keep it simple, make it really simple to move around and bring it on. Questions?
What is the relation to entity component system?
That's coming. I will get there, I promise.
Because on some slides before, you mentioned that the core point for ECS is the entity. But it's not true, it's a component. And,
So I have a slide.
okay.
Don't worry, it's coming. Yes, absolutely.
This isn't a question, it's just more of a comment.
Yeah.
It's a really short comment, I don't know if I really mean this. Okay. When you're describing that, the instant thing that comes to my mind is the GLTF format, just because it's kind of a similar thing that you're talking about of having your scene graph, having a bunch of nodes, define everything, and then additional metadata that I guess in this case would have been the semantical properties. I don't know if that's been like a consideration as well or influence in your mind related to this.
So if you have a look at that, you just search Nick Porcino last mile interchange. He talks about USD versus GLTF and he gives some interesting context on that. So I won't go into that too much, except that USD, I think GLTF is more of a, just visualize it at the tail end, whereas USD is intended to be all the way up through the design and creation process from the very beginning. So in terms of the intent, there's some differences, but I do know that, you know, the USD folks and the GLTF folks are they're quite connected, and there's connections there, yeah.
But there is one important distinction, right? That's this indirection in USD, that your layer does
Oh,
not
hang
be
on, we haven't talked about layers yet. We haven't worked it, but sorry, okay, you're jumping ahead. Okay. Before we get to that, when we talk about prim identifiers, how do you identify things? In our industry, we talk a lot about GUIDs to identify things. In USD, things are identified by their names, which can be some kind of GUID, and there's a proposal working its way through USD right now to allow dashes in the names of things, so you can actually put a GUID as the name of something. But in addition to that, there's also all the parent nodes in that scene graph. So the definition is that full, like, if you want to identify and refer to something in a USD stage, you know, here I've pulled the hierarchy from IFC, it's that whole thing. And there's not a huge amount of information about why, but they kind of have this quote that says, we tried GUIDs, it went badly, we don't use GUIDs. And so you kind of feel some scarring in there. I don't know, but this is a decision they made. No GUIDs. Right. Any questions about that? And we'll get into what Thomas was segueing us to. Yes.
Maybe got a point on the GUIDs there versus names. It's just basically for your comprehension. So when people talk about stuff in review sessions, it's a bit easier to understand rather than talking about GUIDs.
Yeah, exactly. Yeah, you're able to structure and name the parts of things, and it's a bit more human readable. And yeah.
But they in trade have to do this periodic reworking of the scene graph tree in trade for, there are costs that they incur in their workflow.
Yeah.
So it's not like it's all smooth sailing by not having GUIDs.
Correct. And I would say that in terms of the behaviors and expectations between the industries, this is a point that's quite different between the VFX industry, because they're used to scene graphs, and our industry where people aren't used to scene graphs and organizing things in a tree. Yeah. So that's all about what you do when you get a USD file and you look at it, right? The question is, how do you write a USD file? So here we're going to go to Sergey's question. We're going to add some more terminology. So we've got what a model and an object is, but then the question is, what is a sub or a partial object? And so IFC doesn't really have IFC doesn't really have a way, IFC4 doesn't have a way of expressing part of an object, right? In ECS, you can have a component, and a component is part of an object, and there you can group them together in some kind of container. I don't think we've settled exactly on a terminology for that. USD has a super clear terminology. They say prim specs are stored in layers, and a prim spec is a specification for a prim. And so you're not able to write a prim. You can only write a prim spec. And you can't store things in a stage, you can only write them in a layer. And in the typical usage of USD, a layer is a single file. So you can write a single file, which is called a USD layer, and in it you have a bunch of prim specs. Now, if you open that file and there's no references to any other files, every prim spec will become a prim and your layer will become a stage. There's like a one-to-one mapping. But that's not the end of it. So yes?
But then wouldn't you call in the IFC world group of partial objects a file?
Well, but the IFC4 doesn't really have a way of opening two files and combining the things together, right? It's you have the object in a file, and there's just it's not part of the current IFC world. So then to get to the comparison between USD and ECS is they do the same thing in the sense that they allow multiple people to author opinions about data, and then they bring them together. Now, you can think of ECS as a bundle, right? You take a bunch of components and you bundle them together, and that becomes the definition of your entity. USD does the same kind of thing, except they turn it 90 degrees and they say, oh, okay, you know what, your prim spec is like part of a prim, and we're just going to layer them on top. And we're going to grab all the bits and pieces from all them, we're going to layer them on top to create a prim. So you can have multiple references, and you can stack all these layers together, and when there's just different data from different layers, they seamlessly show up in the stage. When there's conflicting data, they have rules for which data to present as the winning, in a sense, opinion, but you can also then access all of the different opinions on that. So in a sense, this is what you write. And the only difference between this and what we saw before is that you have sublayers. You can say, hey, this is my layer, and by the way, import this list of other layers as well. And they get pulled in. Yeah.
I think I'm missing what a prim spec was.
So,
Or how,
yeah,
relative.
just let me come back to you after the next slide, and if you're still confused, hit me again. So, layers overlapping prim specs, oh, here you go, this is the answer. Overlapping prim specs define the final prim. So a prim is like a stack of prim specs. That's how it looks. And so you have these multiple layers, and they get stacked together. And the word that USD uses for this is to compose. So we need to be careful. I'm from Montreal. We have a lot of bilingualism, and there's this idea of faux amis, which is false friends. The word compose is a false friend. So when an object is made up of smaller sub-objects, I think in IFC we talk about composition and decomposition, whereas in USD they kind of talk about the model hierarchy for that. When you are creating a model or a data set from multiple sources, we talk about federation, they talk about composition. So if you're diving into USD and you see compose and you use the word compose from the IFC world, they mean something completely different. So this is the idea, is that when you look at the model, you see one stage and one set of prims. And then you can poke at it, because the USD core open source software, what it's done is it has opened 10 to 100 different files and overlaid all the data, and you're able for every single property to see which layer, which file that came from. So in a sense, which author authored it. Dennis, does that clarify somewhat?
No. I mean, is a prim spec a specification for prims?
Yes.
Okay, so it could be, would it be like the schema definition or?
So let me give an example, okay? So like, let's say I've got a prim and it is a chair and it's got two properties, color and height.
A chair instance.
Chair instance, yeah. And I write that out to a file and I give it a name and I say it has these two properties, it has height, it has color, boom, boom, right? When I write that to a file, that is a prim specification. It's just, on the one hand,
What's the encoding of the?
it's the storage.
Okay.
So it's not the serialization, but it's the storage of it. And then when you read it, when it gets loaded into memory, then it becomes a prim.
Okay.
Because it could be that there's another layer that also says it's wood and adds that other data. So you have two prim specs that then are overlaid or composed together to give you the prim that you're looking at. And so from a user perspective, you're like, I've got one data set, this is great. And what USD is providing is just taking all the different bits of data and pulling them together so you can see that one, so that it looks like one data set to you. And then they also provide you tools to kind of peel back and say, okay, well, I want to know who said this and where did this come from. Yeah.
So like another prim spec could be the cost of it or something.
Absolutely, yeah. You could have, one layer that has costing data, that the cost is, you could have the QS maybe publishes another layer with prim specs that have the unit class or the master class encoding. And then when you open these files, it's like, hey, these things all have master class encoding. Oh, they came from the quantity surveyor who went and assigned that to everybody. Yeah. More confusion?
No, not really confused on my end. I feel like I'm getting ahead of myself on the question, so.
As you know, I have no trouble saying, hang on a couple slides.
But yeah, feel free to like tell me, we'll talk about this later, but something that I'm just kind of curious about with like the prim specs is there the possibility of like references with them in the sense of, hey.
So literally the next two slides.
Oh.
I glossed over the piece where you said, what do they use is to identify, I guess, prims or whatever the stuff is, if it's not UUIDs?
So they just give them names, and every prim has a name, and so the identifier of a prim is basically the concatenation of the name of the prim and all its parents.
And those names are like Joe, or are they more like UUIDs or something?
So-
some unique identifier.
So typically they're human readable,
Okay.
and USD, the standard itself, doesn't impose anything. So from what I've read.
So the uniqueness comes from its position in this.
Correct. Yeah. And so from what I understand, every production tends to pick some kind of hierarchy and tells everyone to follow it. So if this was in like a BIM world, part of the BIM execution plan would be like, this is the hierarchy of data in our model. Please follow this when you add stuff. Don't add stuff in a random place. Right? That's and I say that not to propose this, but just to explain kind of. It's not like the standard allows you to do that, but doesn't impose anything. And we'll get to. There's ways to impose something on that. But yes.
At the moment in IFC, we've got the ID and then we've got the name as well. So we do have both. But do you know actually how hard it is to get designers to name their things in a consistent way to a syntax that we define on a project? It's near enough impossible. So to actually record the whole tree within a name, which I actually think you're going backwards because you put it to a string. I'm not very comfortable with that.
So what I will say to that is that USD, the standard, doesn't care. Your tree can be the root node, which is when you add things into a layer, into a stage, it creates a virtual root node, so you don't need to define it. And you can just have a flat tree where just everything is named by a GUID all the way down. You can, right? You don't need to have a deep tree. You don't need to have any kind of hierarchy. So that the standard, like USD itself is like, sure, you've got a million flat objects. Nah, knock yourself out. Right, so that's something that this is a capability they provide that you don't need to use. Right, you could just
still need to be unique, right?
Well, in that case, you just fall back to a GUID situation, right? You can have in a sense, a bag of objects, each with a GUID, and USD will happily let you do that. Yeah.
I think we need both still, because the GUID is the fallback, because it's obviously machine generated. And yes, we do need to get designers to start naming things consistently, but that's down to humans then. And that's
Exactly, yeah. And I mean, and you could have you can put GUIDs on a prim separate from all this hierarchy, right? You can still, do that. So jumping ahead, how do you create these prim specs? And there's three kinds of prim specs. The first one is a define. You can define a prim spec, and what that will do, when it gets read in, it will create a prim and stick it on a stage. That's just how you create be careful with the word instance. I got a fuzz ME coming up for instance as well. But that's how you create something and you place it. You can also create an over prim spec. And an over prim spec says, hey, I've got this prim and I want to add this data to it. And if the prim doesn't already exist, just ignore this. So for instance, someone who's doing a fire rating might have a layer with a whole bunch of overs that are adding some data to existing prims. And then the architect deletes a wall and that, you still have the old file, then USD just ignores it. It's like, okay, well, I'm trying to add a fire rating to a wall that doesn't exist, but it's an over, so I just ignore it. And the third kind is a class, so where you can define a prim spec, but when that gets opened into a stage, it doesn't get placed in the stage. So it's available as data in the data set, but it doesn't get actually put in place. So for instance, you might have a manufacturer that says, hey, here's a USD file with a bunch of toilets in it, and you can reference that into your stage, and you don't get a stack of toilets at the origin, which is kind of not something you want.
So is this sort of related to the entity concept in ECS? So we're not defining the prim sets, now we're talking about the prim itself, which is a composition of prim sets.
So these are how you create prims. You can't create a prim. You can only create a prim spec. These are the three kinds of prim spec. And they instruct the composition engine what to do with that to compose the
Okay,
prims.
so is this slide correct? So are we talking about prims or prim specs?
Yeah,
So a prim spec is a component, right? And the prim is the entity.
Yeah.
correct.
It doesn't exist.
So are we defining and placing an entity?
We're
Should
creating,
we
we're
entity
creating,
more?
we're creating components.
Okay, let me rephrase this, okay? So a def prim spec will, during composition, the USD engine will create and place a prim on the stage following the deft prim spec. In an over prim spec, the USD composition engine will add information to a prim that was created as a result of a def somewhere else. A class prim spec, when it gets composed in, will define a prim that sits there somewhere in the hierarchy that can be referred to and used, but it doesn't, when the renderer goes through to visualize it, it ignores all the classes.
Okay, it'd just be good to put prim spec on this slide somewhere.
Yes, noted. So that's one concept of these different kinds of prim specs, and then you have these things called composition arcs, and this goes to the question. So I'm going to give a fuzz ME alert about instances. So first of all, so when you take some kind of catalog or library object and you put it somewhere, so you say I've got a Revit family and I'm placing it in it, we kind of think of that as instancing in an IFC world. In the USD, they say reference. And in the USD world, when they talk about instancing, they're talking about making a guarantee that this object is not going to be changed and no one's going to do anything to it, and you can fire that object all the way deep into your rendering pipeline as one copy. So for instance, you have a tree with a bunch of leaves, and the leaf is just placed all over the tree. You want a way to tell the renderer, you don't need copies of this. That's what instance means in the USD world. So that's just a warning. You read it and you read instance, they mean something very specific and different than what we mean. So composition arcs are ways to assemble a scene graph. So the first one is a sublayer, and that's basically, I open a layer and I say, hey, open these other layers, and whatever data is in those layers, include it in all this and layer those together. So that's pretty straightforward. Reference says, okay, if I def a prim spec and I say that this prim spec references another prim, what that means is take that subtree that I'm referencing and place that subtree here. Not move it, but place it looks like a copy to the end user here. So what a typical thing that you would do is you reference a sublayer with a bunch of classes. So you have sublayers, and one of those sublayers has a bunch of classes. And then when you want to place a toilet in a particular place, you define a prim, you define the transform for its geometry, and you say it references toilet model 72. And then boom, that appears in your scene graph. You also have things called payloads, inherits, and specializes. These are different kinds of references with won't get into that. but they're like references but different. And then you have variant sets. So there's ways of defining variant sets, and you say, okay, well, I want this variant or that variant, and that could be any set of properties you can change. So you can actually publish different variations and let people downstream pick a particular variation. So whether that's useful to us, I don't know, but that's something that they have. So just for example, you have, like I said, you have a library layer with a bunch of classes, maybe a class prim spec, and then this is referenced into someone else's layer, and when that layer is open and create a stage, that library layer is there, but nothing is placed on the stage. And then a designer defs a prim spec that references the class, and then this places that object in the stage. Questions? Okay, I'm over time, so I'm gonna keep going. Schema domains. So schema domains are how you control the data model and the names and things. So they have a couple of different kinds of schemas. They have an is a schema. So an is a schema is kind of like an object-oriented class or like an entity in IFC4. Every prim can only have one is a schema. So when you write a prim spec, you can specify one is a schema. It can only be, it is a IFC beam. It isn't something else. So it's only one. And if there's two prim specs that overlay and they have differences of opinion, one of them is going to win. So when you get a prim and a stage, you can say, hey, what are you? And it will tell you what its is a schema is.
Sorry, wait. Now we're defining schemas on the prims, not the prim specs? Is that right?
No, we're defining them on the prim spec,
Yeah.
but when you read it, like you can think of it this way. You write prim specs, and you read prims. And there's magic in between.
Right, yeah. So, but when we talk about the schema, I'm hanging on by my
Yeah.
fingernails.
Yeah.
When we talk about the schema for the definition of the data, we're talking about the prim spec, the definition of that data, of that prim spec. And then there's another layer, which is how it gets composed. Right? Or are we
So
talking about
the schema is a property of a prim, right? Of a prim, right? So if I want to say that this prim is this schema, well, the only way for me to say that is to write a prim spec that says this is a IFC beam. That will get composed into a stage, and when I read it, I say, okay, what's the schema of this prim? But when I write it, I have to write the schema on a prim spec. You can think of it as kind of it's a bit of a mind melter, but it's a one-way loop.
I should shut up, but it seems like there should be composition rules and there should be data definition rules.
That is correct. There are composition rules.
And a schema would seem to be more about the data definition.
That is absolutely correct.
So why is a schema about the prim and not the prim spec? The prim spec is the data definition, is the data would be defined.
So you can have multiple, okay, so let's say I have an IFC beam, and then let's say it has a length and a material, right? I can have one layer where there's a def prim spec that says this is a beam and it's this long, and that's it. I can have another layer that says what the material is. So the composition is orthogonal to the data model.
Let's keep going. Schema is about the prim, not the prim spec, and somehow that translates into a composition of prim specs, and those things have their own, I guess.
Let's just keep going. Yeah, an API schema is a schema that you can apply as many as you want to a prim spec, or if there's multiple prim specs that define multiple API schemas, when you get the prim, you'll get that full list of all the API schemas. And they're kind of like an object-oriented interface, or they're like a property set, in the sense that they're a thing that you just kind of say, oh, this has this property set attached to it. They can be applied or not applied. Won't go into that because I'm over time and it's confusing. So schemas define the name of properties, they define default values, and because USD is like written in C++, you can actually define behavior on it as well, but relative to what we do in our industry, we tend not to use that. It's optional, and you can have code-free schemas or codeless schemas that don't have any of that. But the idea is the schemas define what the names of the properties are, what the types of the properties are, and they can define default values. They're grouped into domains. So USD Geom is a domain, USD Shade, USD RI, which is a bunch of data used by RenderMan, and USD Physics. And I think USD Physics is an interesting one because that's one that Apple and NVIDIA have agreed on. They've agreed on the data model, but they each have their own physics engines, separate independent physics engines that will do, in this case, it's like solid modeling, sort of like, you know, the animations of brick walls falling down, that kind of stuff. So they've agreed on the data model, but then the systems is independent and outside of scope. I'm just going to keep going. Interrupt me if you have questions. So validation. They have, this is again a quote from USD, it's very flexible, and every site or studio using USD can establish their own rules and patterns. Fantastic. It's something you can do a lot with. So they have a validation framework. I think this is brand new. The latest release of USD has the first edition of this. But it's a mechanism for creating tests that can validate composed prims. It can validate stages. You can have rules that operate on composed prims, rules that operate on stages, or rules that operate on individual layers. And they're specified as tests. So you can have sort of arbitrary things. And so, you know, we talked about the validation framework. They have a bunch of plug-in things ready that you could write a validation framework on top of. So we're wrapping up here. In terms of the organization, it was developed at Pixar, open sourced in 2016. About a year ago, the Alliance for OpenUSD was created to work toward ISO certification. So at the moment, it's not an ISO standard, it's this open source project from Pixar, but I think the timeline is 2 years or so. They're aiming for ISO standard, or maybe that's aggressive. I saw something, right? There is an AECO interest group, part of the Alliance for OpenISO. Hi, Angel and Sean, they're the co-chairs of that. And then there's a bunch of people that sponsor. There's a fair bit of involvement across different industries behind that. So it's no longer just a thing from Pixar. It's sort of taken on a life of its own beyond that. So just to recap, USD provides a robust mechanism for composing or federating a data set. I didn't update the slide there. Sorry, a data set from multiple authors with sub-object granularity. A performant open source core for working with massive models. This is just a big driver for the VFX industry. They have multi-gigabyte data sets every day, and the performance is a huge deal there. And an extensible framework for defining data schemas and organization and all kinds of stuff. The stuff you can build on top of that. So if we just run real quickly through that list that we had from Leon, can multiple authors contribute to a shared data set? Yeah, different people can write different layers that then get composed into a stage. The geometry of the data is stored unambiguously. They have made choices that allow the geometry to be pretty unambiguous. The ease of implementing readers that can just read all the geometry and data. You might not understand the schema, but you can read the properties, because at the end of the day, everything's just properties on prims, and you can show it to your users, and you can work with that. And if you also understand the schema, then you're next level, and you're going beyond that. Being able to reference third-party data. There is a payload mechanism I didn't talk about where you can actually refer to, I think, like point cloud data and other data formats in USD. Modular data schemas, so we saw that. There's like USD Geom, USD Shade. You can write your own schemas and add them onto that, and they're independent, but they're all in the same place. So being able to integrate data sets with IDS5 and BCF5, I've got these in quotes, like the next generation. Prims in USD don't have to have geometry, so like a BCF issue could just be an object in your data set, stored in a separate layer. We want to express, and this is a verb, not a noun, express libraries of objects that can be placed in a data set. So we talked about how the class and reference system works to do that. Being able to add properties to library objects, I didn't go into too much of that, but with USD, you can take someone's library, override some things on it, and then refer to that in your project. Performance is something that they care a lot about. provide the basis for partial atomic transactions. You can take a subset of your data and store that as a layer and then send someone that layer, and then they can put it on top of their data, so you can only send the changes. Express arbitrary relationships between objects. I didn't go into that, but there's two data types, a relation and a connection, which allow you to express arbitrary data graphs. Express the difference between two data sets. You could, in theory, use USD to say, I've got this stage here, please compare them, and then write me a layer that turns stage 2 into stage 1, and that layer is like the delta of the two, so that's a possibility. Supporting audit trails, I think Alexa said yesterday about there's this divergent thing about auditing and QA versus the technical.
On that, like the DOTs have a dream for digital delivery.
Yep.
And this appears to kill that for IFC 5, where they would have to use like land XML to describe the geometry in the 2.5 degree format that they use, that their standards are based on.
Okay.
And so in this model, you would have the IFC that would just show the information, and then you would have a prim that would point to the land XML file that would have the geometry for the profile and the alignment.
So the key message I want to get across is USD is really flexible, and you could do that. You could also define a data schema, like a schema domain, that had native inside USD.
No, I totally get that,
Yeah.
but like we measure stopping site distance via profile.
Right.
Right, and I couldn't do that in this IFC 5. So I would need to point to the land XML file to have that geometry. So when I go to court, the contractor can pull up that profile and say, the engineer was wrong, they designed a bad thing, stopping site distance was incorrect, and they hit the car in front of them because they didn't stop in time because.
So USD as a foundation would allow you to do it with that external reference, or would allow you to write the data schema to have the alignment directly in the file?
This is the business logic versus geometry.
Right, and so the goal of the DOT is to have it as a digital delivery. So
Yep.
they get the model,
Uh-huh.
right? But then when there's a lawsuit or something happens, how does the contractor then prove the
Right.
design?
So what with USD, because you can sort of do this layering, and the layers are at runtime combined together, I can have a signed model, digitally signed, and I know it hasn't changed.
Right, but there's not the data in that model that allows me to validate the design.
No, you can put the data in the model, and the signing would include the signing of the individual pieces, and also the manifest of everything. So if that land XML file was an external
Right,
reference.
now I'm relying on land XML instead of IFC.
No, that's a bit of a red herring, I think, because that's a choice that's not imposed by this. You can
But
create.
I would go into the basic geometry of it, right? Like when Devin mentioned we're going to basic.
Okay, so on that, all I'll say is I was presenting the choices that the USD people made. The geometry stuff is not core to USD, to the composition. We can make different choices and still use that core, right? We can say, you can render out this geometry using the USD geometry thing, but you also need to have the full profile defined, because that's the reality. That's a choice that we can make in using this as a tool. Like, it's not something that the tool imposes on us.
No, I totally understand that, but it just, from your talk and your talk, it seems like we're throwing that.
I don't see alignment as geometry. Alignment is about placement, so you can still find your alignments in IFC without geometry.
I mean,
I think we'll see that in the next one.
So the if we get to the bottom of this, we'll be here all day, right?
yeah, I would move on.
Yeah. Okay. So I can take someone's signed model, and then I can create a layer that references it, and I can work with that model, and I can add data, I can modify, I can make suggestions, I can augment it, all with keeping that data trail. That original model has not been modified, and it's very clear when someone opens my stuff what data I've written and what data is part of that original signed thing. So there's like a mechanism to actually have that QA and audit trail and the technical, it's not like, okay, I've got this signed and it's over there, I can never use it. Well, I've signed it, but I can keep using it. And it's open to extension with, if you're on your project, you want to have a little data schema that you use on your project, you can do that. You can have that next to IFC with your own little data extension. And then, of course, you can validate data sets against the IFC schema, against everything, right? There's this mechanism for validation built in. And, sorry, I'm done now. Any questions?